Good evening or good morning, everyone, and thank you for joining us at the launch event of the Comunica Association. So for those of you that don't know the association yet, the goal of the Comunica Association is basically to be a non-profit organization that aims for the long-term sustainability of the Comunica query engine, where the Comunica query engine is an open source framework that enables you to query knowledge graphs on the web. So for the launch event of the association for today, we have the following schedule. So to begin, I will start with a very brief introduction explaining in a bit more detail what the association is and its plans for the future. After that, we have four invited speakers from different companies and organizations. And I'll introduce all of them in more detail after I give you this very brief introduction. So I want to briefly talk about two things. I want to talk about the experiences we had with the association so far, and then I will very briefly present the current roadmap of Comunica. So a little over 1 year ago, we had a soft launch of the Comunica Association. So that was on June 21st. And during this soft launch, we introduced the so-called bounty program. And the goal of this bounty program is to connect companies that are in need of certain functionality in Comunica with experienced developers. So the idea is that if companies that are using Comunica would, for example, run into a certain bug or were in need of a certain feature, but they lack the expertise internally to implement this functionality, they could place a bounty on this functionality, and then the association will look for a suitable developer, like a freelance developer, that could resolve this issue, and then also get paid for implementing this functionality. So far, we are seeing that this bounty program is gaining popularity. In the past year, 18 bounties have been placed so far. And from these 18 bounties, 8 of them have already been completed and 4 are still being worked on today. And this all across 6 different freelance developers. In total, we have paid almost 6,000 euros to developers with almost 5,000 euros still pending for the running bounties. If you want to learn more about these bounties, you can find more information on this link here on the bottom. So a couple of months after the soft launch, we introduced a way to become a member of the association, where the goal is that members can collectively determine the roadmap of Comunica. So there are 2 ways of becoming a board member to the association. So either you can contribute time directly to the association, or you can give a certain budget each month, using which the association can then hire a dedicated part-time core maintainer. So for organizations that are not interested in determining the roadmap, it's also possible to become a sponsor of the association, where you also have certain advantages then. All right. So far, we have 3 members. So we have members from IDLab, Digital Flanders, so from the Flemish government, and from Australian National University. And we also have 1 sponsor, the Dutch Digital Heritage Network. If you want to learn more about memberships and sponsorships, you can find all details on this link. Then one last thing for this part that's important to mention. Everything we do in the association, we try to do as public as possible. And this also includes making all of our finances public. So on this page here, you can see a screenshot of our public open collective page, in which you can see the current state of our budget, but also all incoming transactions and all outgoing transactions. So all of this happens very transparently. All right. So this was very quickly what our experiences so far are. Let me now briefly present the current roadmap of Comunica. So this roadmap has been established a couple of months ago by the current board members, and this is something that is periodically updated whenever the need exists based on the current board members. So the current roadmap consists of 4 major directions we want to focus on. The first direction focuses on future-oriented development, where we want Comunica to become a testbed for new techniques and features, such as the work around RDF Star, Sparkle 1.2, techniques like WebAssembly, and so on. The second direction, and here we focus on improving overall performance. Of course, this is something that can always be improved, but in here we focus on improving, or implementing new algorithms and implementing new low-level query optimizations. In the third part of the roadmap, we focus on improving developer experience. So both the developer experience when working with Comunica and when working within Comunica. And then the final part of the roadmap is a bit of a special one, where we want to connect more with other developer communities that have overlapping interests, such as, for example, the Rollup.js community and the RDF.js community. More details on this roadmap can be found on this link here. And this is, of course, something that will also evolve over time. All right, this was about everything I wanted to talk about. So to summarize, the goal of the Comunica Association is to make the Comunica query engine and all tools around it more sustainable in the long term. And we do this by financing development on the roadmap using budget provided by sponsors and members. And we also do this by connecting companies with experienced developers through the bounty program. So if you are interested in either becoming a member or sponsor, or by placing or claiming bounties, you can find all information on the website of the Comunica Association. So comunica.dev/association. All right. Before we go over to the next speaker, there's just one more thing I want to mention. Next week, we will be present at the Semantics Conference in Vienna. So if you're going to be around there, be sure to come talk to us there. All right, so let's get back to the schedule then. So the next speaker for today is Enno Meijers, who is from the Dutch Digital Heritage Network, and he will be talking about how they are using Comunica within their heritage network services. So Enno, feel free to unmute yourself and share your screen whenever you want.
Thank you, Ruben.
Stop my share.
Okay. Thank you, Ruben, for the introduction and for inviting me to talk about what we do with Comunica at the Dutch Digital Heritage Network in some of the services we built in our digital heritage infrastructure in the Netherlands. Before I go into the details, I think it's useful to have a very short introduction of the Dutch Digital Heritage Network. As it's not a regular organization, we are actually a network of basically all the heritage institutions in the Netherlands working together in order to improve the visibility of digital heritage information in the Netherlands. We work together with the Ministry of Culture, and we're working from a national strategy in order to increase the social value perceived by basically all the people in the Netherlands, the social value of heritage information. And it's basically driven by the need to do so because there have been a large number of digitization projects in the past. A lot of work is done on digital collections, but in the end, it's very difficult for the user to really find the information, because you really need to know the infrastructure, the places where digital information is found, how to find all the search engines. So we're working on a national program, and it already started in 2015, in order to make the digital heritage information more sustainable, more usable, and in the end more visible by doing so. For this talk, it's quite interesting to know that basically the linked data is conceived as one of the enabling technologies in order to achieve this goal. So, and of course, if you talk about linked data, then all the stars from Tim Berners-Lee come to mind. And I will be focusing especially on the fifth star, how to get really the URIs in your data. That's basically what we ended up using Comunica for, and it's very important application for us. I enjoyed showing the 7-star linked data here from the colleagues in Finland, because they also stress the need for a good schema and documentation, and the quality of data and provenance, which are in the daily linked data practice sometimes get too little attention. Just to take you in our problem area, we basically in our network we have about 1,500 institutes that publish data on the web one way or the other. And I have examples of art objects and publications, all about our famous painter Vincent van Gogh. And of course, luckily he is defined in our network as a linked data resource in the network through the artist database. So in the published linked data from all the objects descriptions, you can link, you can make linked data links, triples to the URI of Vincent van Gogh. And this is of course a very important part if you want to build linked data. And in order to find the proper URIs, we developed a service called the Network of Terms, and I will be talking more about it in a minute. But coming from the end user perspective, it's very important to have a way. Suppose you're a user and you're just interested in all the work of Vincent van Gogh or everything that is published about him, then it must be possible to go the other way around as well. And for that, we are developing knowledge graph services, but we're doing this on the network level, and that means that we don't aggregate all the data that is in the network, but we just try to build discovery services within the network. So you can build services that make use of additional information, where to find the data and how to use the data. And for that, we have built a data registry. And the data registry basically defines all the cultural heritage data available in our network. And for both of them, the Network of Terms and the dataset registry, we are using Comunica as a way of performing searches over the linked data. If I zoom in on the Network of Terms, I just listed a number of resources we have in our network that we provide through the network of terms and that are relevant for linking digital heritage information. And as you see, these are really, it is quite a diverse set of sources. Some are international, some are national sources, and even we have regional sources like all the streets in Gouda. And for different purposes, they all can be relevant, and basically network of terms helps the maintainer of the information to find the right URI for his string, basically. And this is, of course, a very basic problem. So you have the string Van Gogh, and how do you find the URI that is most relevant to use as a replacement or as a link to the resource on the web. It can be done through the collection management system, and you can think of a situation where you maybe aggregate all the different sources into your system, or where you build APIs to each source. But in the end, it becomes a very hard job to do so, especially when you have multiple sources. So you have to deal with different protocols, you have to deal with different data models, and of course you need to think about maintaining the complexity or a synchronization with the sources. So in order to solve this problem, we developed what we call the network of terms, which is basically one single API to all the different sources available in the network. And in order to make the use or the implementation of the API of the network of terms as easy as possible in the collection management systems, we did some transformation there. So we made sure that everything you look for is being returned as a SCOS modeled object, so you always know what you get back. And we do translations from all different kinds of data modeled in schema.org, in SCOS vocabulary, but maybe also things like DC terms. So that's one step we take. The other one is that we provide a result through a GraphQL interface. And we really did this in order to make the implementation barrier as low as possible. So in the end, we just provide a very simple JSON object modeled through the SCOS vocabulary, and it can be implemented basically in any system. For querying, we use the Comunica, and we use it as a tool for performing the federated queries over all the different sources, and that is basically also the scope of the network of terms. It requires the sources to be able to provide some sort of linked data interface, so it can be queried. And of course, Comunica is very helpful in querying all different kinds of linked data interfaces. Sometimes, like we did with geonames, we help the source to become available as linked data. So we made a selection of relevant entities from geonames and published them as linked data, as a linked data service, in order to query them through the network of terms. So by this way, we really made it very easy for maintainers of cultural heritage information to search through the network based on the strings they have been assigning for basically for ages already, and they can find the proper URIs for that and use them. So when they publish the data, we have the links in order to connect all the different pieces of information coming from the different institutes. The software is available as open source software on our GitHub. And there you also find software of a data registry I was talking about, if you're interested. If you look at the repository of the network of terms, and you're interested in the way we use Comunica, have a look at especially this package, the network of terms query package. There you find the most details about how we use it. There is you can find a link to the demonstrator. It's just a front end in order to see how the network of terms work, and also there's a playground interface for the GraphQL API if you like to play with it. Currently, this network of terms API is in production and has been implemented by a number of commercial vendors of collection registration systems, and also in a number of open source tools that are developed in order to maintain digital heritage information. To conclude, I want to mention something more about an interesting pilot we did together with the team of Pieter Colpaert. And it was about autocomplete functionality. As you can imagine, what we do currently is just send a query string out to all the different sources, and we just wait till the results come back, and maybe in the client order the results and do some sorting, or even simulate a sort of autocomplete functionality. That's of course not the ideal situation, but it is the way currently we can query over these federated sources. So we worked together with the team of Pieter on an experiment on an autocomplete functionality based on the tree specification. And if you have any questions about details for this, please ask Pieter and not me, because it's not my area of expertise. In the end, I think we made a very interesting pilot showing that searching in an autocomplete in a way through different terms, like is shown here, looking for just typing and seeing the results come up in a very, you see times mentioned here in a very fast way. And it was really an interesting and impressive experiment, actually. The software is currently published in a branch of Comunica and in combination with the tree. It's called Comunica, as I learned earlier this week. And the magic, I think, from tree is that the linked data is already fragmented in a special way, so you can use the querying algorithm in order to step through the different fragments of the data based on every time the query changes, it chooses a different fragment. And I think it's a very interesting solution, and I hope this work will continue. And I know that Pieter and his team will keep working on this. Like Ruben mentioned, we are sponsoring the Comunica Association, and I think it's a very interesting initiative, and I really hope that it will be successful and will continue to exist, because I think it's very important that these kind of very useful open source projects have a good foundation and a way of really be sustainable in the future. And through this way, we have already two bounties that resolved some of our requests and issues so far. So we're very happy about this initiative, and yeah, we hope it will be very successful. So thank you for the attention.
Thank you, Enno, for the very interesting presentation. I don't see any questions in the chat yet, but to the audience, feel free to ask them in the chat. So in the meantime, if there are any questions from the other speakers here, feel free to unmute yourself and ask Enno any questions.
Yeah, one quick question, by the way, cool presentation, Enno, as always. So you show a lot of slides in which we see Sparkle, but also sometimes GraphQL. GraphQL is, of course, a very popular query paradigm, so very understandable that you also support that paradigm, but it doesn't have make use of standardized schemas. So how do you sort of resolve that in practice?
Yeah, good question. I must say the use of GraphQL is something that's being discussed a lot in our team, as we think it's well, we have different thoughts on using this, but we really did this in order to lower the barrier for a broader use without the around the linked data community. I must say, of course, the queries we sent out through through Comunica are, of course, very basic. It's about a string that needs to be searched through in all the different Sparkle endpoints, and there's actually something that's full text search in Sparkle, and that is something that's really challenging, as we learned, because every triple store vendor uses his own magic to do optimization in full text search. So that's something I hope Comunica will really work on to make things easier to use. So that will be on the roadmap one day too. So the model we get, the model we use as input is really simple. It's basically a query string, and what we get back is the SCOS representation modeled as simple JSON. That's basically what we get back. So you get the ordinary SCOS, like SCOS broader, narrower, preferred, and those kind of labels. Does that answer your question?
Yeah, definitely, thanks. And I also recognize the challenge, like GraphQL is more widely understood in the current development community. So very wise choice, I think, to try to address both. Yeah, thanks.
Okay, thank you.
I see a question from Pieter.
Yeah, I know a great use case, in fact, to be using Comunica, but I'm still really interested in what's the defining feature of Comunica that really decided you, or that really made you decide to choose for Comunica. Is it like mainly the GraphQL over linked data, or is it even more than that?
No, as I learned, I'm not the developer. I'm just asking my colleagues to build something. But as I learned, we're not even using the GraphQL features of Comunica. We're just translating them into a Sparkle query, and the Sparkle query gets sent off through Comunica. And the main feature for us was really the federated querying possibility, functionality, and the way it handles all the different possible ways to query linked data, because of course we try to standardize on Sparkle endpoints, but basically you can use any kind of published linked data as input to Comunica, and it's just a very interesting layer, abstraction layer for us. So we can just talk Sparkle to a bunch of linked data sources. That is basically what made it very interesting to us. That's one use case. For the registry, I didn't go in details there, but we expect, I showed one registry as an example, but we expect we will have multiple registries in the end in our network. And so we already choose to use Comunica there. So we're directly building applications that are able to be used in a distributed way. So when we have more registries, our logic doesn't change. We're still doing, we're just sending off Sparkle queries to Comunica. So that is really interesting to make your application very stable and not very tailored to all the different kind of linked data sources there are.
Yeah. And towards the future, what are like for you the next big thing that Comunica should focus on? Is that then if it's federated querying, then probably automated schema alignment would make sense, right? As the next big killer feature.
That would be very cool, actually. Because currently we do that all by hand. We need to tune. We use construct queries in order to do the transformation. But if we get some solution that is more intelligent, that would be really nice, actually. But I think what I already mentioned, standardizing on full text search would be really, really helpful, because we actually program different kinds of query strings, and in the end, before firing them off to a certain kind of data source, we choose which kind of query string we must use, depending on the logic for full text search, like if it's a Virtuoso or a GraphDB, and they have different kind of full text support. So I hope actually that will be in the Sparkle, the next Sparkle standard, actually, that we really come to a good definition of that. But if not, then Comunica could really be helpful.
Yeah, I also think this fits very nicely into the that first part of our roadmap, where with the future-oriented development, and there we also want to focus on participating more in the Sparkle 1.2 community group. And I know that at least there is also a lot of interest in standardizing this full text search functionality in Sparkle. So I think we will definitely see some things happening there in the near future.
Yeah, because that's really interesting. And in the beginning of Comunica, we were always thinking about Comunica as like the Babel.js for Sparkle, like the fact that you would be able to implement very small experimental features, would be able to test it out, and once they're actually getting used in Comunica, then you could say, hey, it makes sense to actually change the spec to really adopt this in this way, because look, all these implementation actually rely on that feature. So yeah, I think certainly with one, language negotiation in Sparkle is something I have also really high up my list. Like the fact that Wikidata does it completely different than Virtuoso, for example, is a clear indication that we need better standardization on language negotiation of text strings, but indeed also for text search. But yeah, then we could go on towards also next to full text search towards geospatial search is being done by GeoSparkle, but then also next to it again route planning, for example, which is a very specific set of algorithms that really need to be able to control the path planning algorithm behind it, which is also not something that is natively supported by Sparkle. So I wonder whether we will put everything into Sparkle as well, or whether we will get also different kind of query actors within Comunica that can say, okay, this query actor can run Sparkle, but look, this other query actor is something completely different and runs, for example, route planning queries, and this one will be able to run auto-completion queries or full text search queries. Yeah. So I wonder how that will evolve. Yeah.
Very interesting. Yeah.
All right, just looking at the schedule, and I guess it's time to go over to the next speaker. Thanks again, Enno, for your presentation. And then we can go over to Wouter Beek from Triply, and he will be talking a bit about his about the commercial services they provide at Triply and how they are using components such as Comunica, linked data event streams, linked data fragments, and so on in their services. So Wouter, feel free to start.
Yeah, thanks, Ruben. So let's see. Oh, the title of my talk is Building a Linked Data Multistore with Comunica Association Components. I have to be honest, that's quite a lengthy title, but I think it covers the content quite well. So let's see. So Triply was founded by me and Laurens Rietveld. So we've been working on Triply for 4 years now. Before that, we used to be academic colleagues of most of the people involved of Comunica. So we used to be researchers ourselves at VU University Amsterdam. Triply offices are also still located at VU University Amsterdam. So we're still very close to active research.
Yeah, but I thought the whole point of this launch event was indicating to everyone that, hey, Comunica is an industry product and is not an academic product. So okay, it originated from academics, but we should really make the point that even Triply, which is a really commercial company, is using it.
Yeah, no, that's good. So indeed, in the arc of my story is, but the last couple of years, we've been definitely trying to commercialize linked data. This was also something from our research perspective, that we always felt that linked data was not really making the final push towards production systems. And that's why in 2019, we started doing some deployments of really large-scale production systems with knowledge graphs of over 100 billion facts. I think in the beginning, that was also our main competing property, that we were able to scale beyond the size of the previous generation of triple stores. In 2020 and 2021, we sort of standardized that into the TriplyDB product, which can now be sold just as an off-the-shelf product. So it's no longer very special for a limited set of customers. It's just a sort of off-the-shelf product now. And 2021 was an important step because there we also went for certification. Because once you're a triple store and you are indeed running in these commercial settings, then you often have to adhere to lots of certificates, in this case ISO, but also other things like regular pen testing. And that allows large corporations to also deploy TriplyDB in their premises. And that also allows us to go head-to-head with Neo4j or Oracle or very big traditional database companies. But that's definitely the competition that we see. We believe that linked data is ready for production, and it also means it's also ready to replace these really entrenched and really big non-standardized databases. At the moment, Triply is still a smallish company, but we are of course growing, as is linked data as a standardized technology. So we're currently slightly over 25 employees. And also we are now starting to fan out. We used to be really focused on the Dutch market while developing our product. But now we're also looking at other countries and involved in the first international project this year. So this is basically who we are. So we're just a bunch of really enthusiastic linked data people. Some of them from academia, but also some of them with commercial experience. And yeah, especially the mix, of course, like diversity in the team is always good from that perspective. So our goal of the company, so we also have a motto as a company, and that's linked data for everyone. This is a very simple phrase, but has a lot of components to it. Of course, the original focus was formulated by Tim Berners-Lee as anyone can say anything about anything in linked data. But that has some implications also for databases. So it means that anyone must also be able to store anything, anyone must be able to query anything, and must also be able to model anything. And I think if we look at the previous generation of triple stores, then they definitely do not fulfill these AAA anything goals. But they are more focused on one company internally can model some data and maybe can also query it to some extent, but not even that scalable. So we definitely want to go to the web, and we want to involve everybody. So large corporations, governmental institutes, cultural heritage organizations, of course, but also linked data professionals, individuals, students, hobbyists, everybody. So from one person to organizations with thousands of employees. Of course, AAA is really inclusive, but of course, everything should be within current regulations, also considering privacy regulations, which are quite strict in the EU, probably for good reason, and also very secure. So also according to the latest certification standards. Now, this is our product, basically, TriplyDB. I'll go through these slides a little bit quickly to get to the interesting Comunica part. But our triple store basically looks a little bit different than other triple stores. So you can actually recognize the data from a domain perspective. Domain experts also like to use the triple store quite a lot. It's very visual. It shows the data model very well. Here, for example, you can see the data model of DBpedia. And again, like it used to be, ontology views almost never really scaled, but in TriplyDB, everything works at scale. So also you can view an ontology of DBpedia, including all of the instance data counts. Everything is done from a scalability perspective. You can generate the national budget of the Netherlands using a Sparkle query. This can actually be done. And you can also visualize Sparkle queries in 3D environments and things like that. And it just means that a triple store looks a little bit different than other stores. Also, end of last year, we launched tripledb.com, and that's a free instance of tripledb. And that means that up to now 600 users have logged in using either their Google account or their GitHub account, and they can just publish data for free and also query it for free. And that's link data for everyone, so it must also include the free users. Okay, I think this introduction is going to be very important because I think that we need Comunica in order to achieve these goals. The we here is very broad, so of course we as Triply need Comunica, but I think also more broadly the link data community needs Comunica. We'll start out with this first goal: anyone can store anything. If you really want to make that very concrete, then you have something like this in tripledb. I'm creating a new data set, and I want to add some data. So I can add data from a URL on the web. That's very convenient for vocabularies, for example. But I also can drag and drop some of my files, and notice that I can have several formats, for example, JSON-LD, and I can just drag and drop a JSON-LD file and everything goes fine. Until it doesn't, of course, as is always the case in computer science. And then, we had actually two users who uploaded a JSON-LD file that was really large, like a gigabyte, which is probably very large, assuming JSON-LD was originally intended for more like API communication. But it's very important data sets. So we have the Deutsche Nationalbibliothek, who is using very large JSON-LD files, and also icon class, which is an important standard in cultural heritage for annotating artworks. So these are not just let's trim down to anyone. Let's just say, okay, so some people, maybe they shouldn't be able to upload their data when their files are too big. No, we can do that. We want to be really inclusive. Anybody can upload anything. And that basically means that we need a solution for this problem. Now, where I would traditionally have started is at W3C. I think I did when I encountered this issue in 2021. So I went to W3C and I asked for guidance on parsing very large JSON-LD files. And then a very nice and probably also super smart W3C employee told me, oh, JSON-LD is designed to be an in-memory format. Okay, that's a little bit annoying, at least from the perspective of Triply, because we want to make it really cheap, because then we can also allow everybody to upload very large JSON-LD files. And if we always have to load them into memory, yeah, then we have to acquire the memory in Azure. Memory is most expensive. It's the most expensive hardware resource. So we're already drifting away from the original goal of anyone, right? We can already say, okay, now you have to pay. If you want to upload icon class or Deutsche Nationalbibliothek, now you need a paid account. We don't want that. We really want to be open to as many users as possible. So that's why I shouldn't have gone to W3C, but I should have gone to Comunica immediately, of course. So Comunica is working on a JSON-LD streaming parser. And already the name of the parser, the fact that it's streaming, already shows that the perspective of the Comunica community is very different from, unfortunately, most of the rest of the community. And I think the rest of the community will also get there, but I think Comunica is a little bit ahead at the moment. So what we really want is we want to solve this JSON-LD scalability issue in a streaming and therefore also cost-effective way, so that we can become more inclusive as a triple store, so that we can really let everybody upload these files for free. Now, this is why we, of course, opened a bug report in this library. And I'm also really happy to say that this bug is already being picked up and is already being developed. So that pretty soon you should be able to upload very large files, including very large JSON-LD files in tripledb. And that includes also for free accounts. Now, there's some similar use cases. Some people also upload RDF XML. That also has to be in a streaming way. And there also we encounter some bugs and also sometimes scalability issues. And again, that is exactly the focus of Comunica to allow this to be fixed. And I think that's really nice that we can do so. Oh, by the way, you never notice RDF XML mentioned in the tripledb GUI. We do support it, so you can upload RDF XML, but we don't advertise that we can do it. I think that's a little bit of let's say opinionated from us, but we of course read RDF XML, especially if you then afterwards export it in some other form. And this was only storing, right? So only the simple thing, like I just have a data file and I want to store it somewhere. Already that doesn't work with traditional libraries. And already there you need the streaming approach. You need the new approach that Comunica envisions. But we can go even further than that, and also maybe a little bit more exciting. We also want anyone to query anything. So not just to store, but that's already apparently a big challenge, but also just to we also want to allow people to query anything. And again, that's where Comunica has a very different vision than most of the rest of the current community. And I try to emphasize, sort of encapsulate that in one meme. This is our modern way of communication, of course. We communicate things in memes. This is a famous meme where somebody has a very expensive camera. You see the cameras hanging over here. They are really expensive. But this person, probably a journalist, assuming such expensive equipment, but the journalist is instead whipping out the phone because that's, of course, much faster, and that allows the journalist to encapsulate this newsworthy item that is, or event that is taking place. So we can basically reuse this meme. I'm not familiar with how to use a meme generator, so I just pasted some text on top of the meme. This is probably not how it should be done, but I hope you get the point. But you can easily have a very expensive triple store or graph database or whatever database. But I think it's very important to look at the sort of new vision of Comunica, but you can also use all of these other things. You can also use Comunica, link data fragments, link data event streams to get a lot of the same stuff done for less hardware cost. But also sometimes you get more done than with the traditional triple stores. These traditional triple stores are very expensive, but they don't necessarily scale. So it's actually a sweet spot of bad stuff. So where do we see this in Triply? So in Triply from the very beginning, actually I think Enno was sort of responsible for this since Enno requested this as a feature early on. But also others would like to use link data fragments. And if you have a data set in TriplyDB, any data set that you upload to TriplyDB also has a corresponding link data fragments API. This has been the case for several years now. And this means that, for example, if you have this DBpedia data set, then you have a corresponding URL that starts then with api.triplydb.com. And then this API link basically allows you to go into Comunica. And then in Comunica, you can just put whichever link to your personal data set. And then you can ask this question. So this question is about which movies is Brad Pitt an actor in. And then when I press the execute button, I can just run this over any data set in TriplyDB. And this is really nice because this means that when you upload data to TriplyDB, you don't need to have an expensive service. You don't need expensive indexing. No, you just upload it to TriplyDB. You get your fragments API URL. You just copy paste the fragments API URL, and then you can basically write Sparkle queries or GraphQL LD queries inside the Comunica environment. That's very simple, and it works for a lot of use cases. Maybe not for all use cases, but that's again the trade-off that we saw in the meme. Of course, there's still a use case for these expensive cameras, but sometimes you just want to flip out, you just want to whip out your phone. Sometimes you just want to whip out your Comunica engine. This is also true for link data event streams. These are not currently exposed for every data set in TriplyDB, but we enable this feature for some TriplyDB instances based on a customer request. I think in due time we will make this available for all data sets in TriplyDB, because this basically allows you to index data sets based on language, space, and time. So three very fundamental dimensions. And of course, if you can index along space, time, and language, you can do a lot more. You can do a lot more things even than with link data fragments. And this is the work that Pieter Colpaert and his group are working on, and it's also being implemented over at Enno's NDE to some extent. So this is, again, something that's really being picked up quite a lot at the moment. But also, Triply wants to have Sparkle. So not just link data fragments, link data event streams. Very often it's the phone you need instead of the expensive camera. But sometimes you want the expensive camera. Let's say Sparkle is the expensive camera here. And we also want to have the expensive camera at some point, but maybe also make that available for free users. We are not there yet, but we are working on that internally. And this is where we reuse a lot of components, because I like to think of Comunica not so much as a complete triple store implementation, although you might use it in some cases like that, but it's especially a couple of building blocks, and we are basically combining the Comunica building blocks with triply specific building blocks, and then you can sort of mix and match your own solution. And this is one of the repositories that we use, for example, and that also some bounties have been written on. Maybe the last thing when we get to this querying and let anyone query, I think we already saw this in Enno's presentation, is that GraphQL is reaching more people at the moment than the Sparkle standard. And I think that also is a really good approach to have a linked data compliant GraphQL implementation. This is not yet integrated in TripleDB, but we do envision for the end of this year, beginning of next year, we want to see whether we can also have a GraphQL over all linked data sets in TripleDB. And then, of course, we'll also be taking a look at this particular repository where a GraphQL compliant linked data approach is achieved. And I think that's really important because if we all start exposing GraphQL, but without reusing linked data vocabularies, then we are not compatible anymore. So I think GraphQL LD is really important in that sense, that yes, we want to have GraphQL, but we also want the schema to be universally interchangeable, and that can only be done with linked data, is my personal opinion. Okay, so basically looking back on my presentation now, so if you are using TripleDB, where is Comunica? Well, it's basically in this, when you're using this, you're basically using LDES. And when you're in this view, you're basically using linked data fragments. And when you're in this view, you're basically using a JSON-LD streaming parser and RDF XML streaming parser. And so you already get the point. You're basically using Comunica bits and pieces everywhere in the Triply product. And I think that's really great, where we can also give some things back to the community, but also as a company, we're able to actually build a product from like a full product, reusing many of these building blocks and thereby also competing with more entrenched companies that are not applying open standards yet. So that's basically my presentation, and just at the end, I think this is sort of where Comunica is going, and I really like that vision. It's a new approach. It's not followed in the past. The past was really focused on big databases, big triple stores, but I think Comunica with a more decentralized, lightweight approach, I think that's really where the future is going.
All right. Thank you, Wouter, for the very nice presentation. I especially liked the fact where you showed really that you're pushing the boundaries of the W3C specs, like with the JSON-LD, that you're running into these scalability issues, and that you're looking for ways to move a bit beyond the current specs to still support that functionality for your users. Are there any questions from anyone? I see Pieter's hand.
Yes. So I in both Enno's talk and Wouter's talk, there's a lot of enthusiasm for GraphQL, but I thought GraphQL was like on its way back already in popularity, in the sense that, for example, GitHub announced that they wouldn't support GraphQL anymore. What do you think about that, Wouter? Is it like a victory for SparkQL, or is there still a future for GraphQL in the long run? GraphQL LD then. Yeah.
In the future, it's going to be a victory for Sparkle, but this is when GitHub announces that they will switch to Sparkle support in 2024, let's say. But that's, of course, a little bit ahead of us still. No, for me, the popularity thing is not necessarily that important, but it's just that in the marketplace, when you get these quotes from companies, from organizations, they want to have certain functionalities. They want to have a REST API. They want to have text search. They want to have graph search, and some of them now they require explicitly it has to have GraphQL. And you, of course, want to provide that as a triple store vendor. But I think at least Triply only wants to provide that if it's still linked data. So if you still receive not just JSON back, but JSON-LD, And if also from the query perspective, you're actually still querying according to the ontology that you specified. And so for me, it's not so much, we're going to create a couple of services on top of a linked data ecosystem that are themselves no longer linked data. No, I think it's the other way around. And we want to incorporate as many paradigms as possible, because sometimes LDES is the best approach, sometimes Sparkle is the best approach, and sometimes GraphQL is the best approach. But when one of these things is the best approach, it's always according to the same schema and always according to the same open standards. And I think that's the most important part for me.
All right.
Any other questions? I perhaps have a very small detailed question. So a bit earlier in your presentation, you mentioned that you support the upload of different types of linked data sources. Do you by any chance have any insights on what types of RDF formats are more popular than the others?
Oh, I don't know this actually, which is a bit strange. So when I was a researcher, I did know this because then we collected lots of files that we found online. But from our active users, I don't think I'm not sure actually. Maybe we log it somewhere. I'm not sure. Of course, we have to always adhere to certain regulations, and it's very important that you don't log things that could identify, that are identifiable at the person level. Maybe the file extension doesn't introduce any identifying criteria, so maybe we are technically allowed to log them, but whether we actually log them, I'm not so sure. But I do agree it would be nice to have this as an insight.
Yeah, it might give some direction on which parsers we should focus our prioritize our optimization efforts on.
Yeah, indeed. Yeah, and like from Tripli's perspective, we just support all the standardized formats, and then just when somebody encounters a bug, we just report it. But of course, it's maybe good to also have this quantification, because then maybe you can say, this format makes more sense than this other format. But for Tripli, in the end, we want to support all the formats equally, regardless of use. So even if a format would not be used that often anymore, for us, that's not necessarily a reason to stop supporting that.
Yeah. I see there's also a question from chat. And that's a question for Wouter, I think. Why not pass the GraphQL versus Sparkle debate? Both, in my feeling, address how to execute a query. Still missing, in my honest opinion, in the linked data landscape is a pure semantic description of what your query is about.
I think to some extent, like the core of that, I agree with, of course, because what your data is about, that's your ontology. So that's your knowledge model in RDFS OWL, or maybe in SCOS, but RDFS OWL would maybe be nicer, maybe with SCOS in it. And your information model, Shackle, so you have your open world semantics that others can understand the meaning of your data, but you also have closed world semantics so that you can enforce your meaning inside your organization. So that's, I think, the best combination, open and closed world. And then you basically allow people to query everything according to those schemas, according to their data model. And whether they use a REST API, or whether they use GraphQL, or whether they use Sparkle, or maybe tomorrow there's something new, who cares? It's all about the knowledge that is encoded in the data. And it's all about the information model, like the constraints and the checks that you have on your data to ensure that its quality is really great. So I think I agree with the sentiment. Of course, we have all of these different query paradigms. Of course, we need to support them because our customers often require that. So if we can't fill in the checkbox for GraphQL, then we would lose some bits. We don't want to lose a bit. We always want to try to win them, of course, in the end. But definitely the underlying idea is that it's all about the logic. It's all about the meaning of your data, the encoding of the meaning, and then the sharing and the interchanging of that meaning. And which query paradigm is more popular today is definitely less important to me.
All right. Thank you again, Wouter, for your presentation. Based on the schedule, it's time now to go over to our next speaker, which is Jesse Wright, who represents the Australian National University and is also an employee at Inrupt. The title of his presentation is "The More You Know, Easy Access to Enriched RDF Using LDflex and Comunica." Jesse, feel free to start.
Thanks, Ruben. Yeah, so to give a bit of context, I've been using Comunica myself for a few years across various projects and have found it quite useful in all instances, from kind of form generation to health data and now at Inrupt. So there's a lot of things I could have chosen to talk about today. But what I am going to talk about is reasoning, which I've spent a decent portion of the last year working to add support to Comunica, and is something we're now using at Inrupt for some of the experimental developments we're doing. So let's just get my slides working correctly. So firstly, I'm aware that some people here might not have heard of LDflex before. So this is something that's also come out of the Ghent research group. And it's essentially a data abstraction for dealing with Sparkle queries when you're doing development. So specifically, it's a domain-specific language in JavaScript that allows you to query linked data. And it means that you can write JSON-like syntax to execute under the hood Sparkle queries. In this case, it's giving you the names of all your friends. And what's reasoning? Well, reasoning I like to think of as getting implicit information out of your data using explicit data and rules. So at a high level, that could be if we have the information that Ruben's a person, and we also have the information that people are all agents, then we can use a rule that says that if A is a B and B is a subclass of C, then A is a C, to work out that Ruben is an agent. So all we're saying is because all people are agents and Ruben is a person, Ruben must be an agent. So this is reasoning technology, like concepts around reasoning that have existed in the semantic web for 20 years. We haven't really had the capability to use it when we're querying across multiple data sources because all our decentralized query engines like Comunica have not supported it up to this point. And what I'm going to do now is walk through a couple of demos to talk through how we can actually make use of this reasoning. Feel free to jump in at any time if you have any questions. This is a very unstructured talk from here. So the first thing that we might want to do is going back to that subclass use case we had before, is use Comunica to ask what are all the classes that Ruben belongs to. And we can do this in our development environment. This is code that's going to work in both Node and browser. So we can get an engine, which is a new query engine. Yeah. And then we can get our results of the query. Select distinct objects where, and here we just need something we're going to query over. And in this case, we'll query over Ruben's identifier. So where Ruben is an object. So this is going to return a stream of results. We could turn it into an array, but in this time, I'm just going to listen to the data event. So results.onData, bindings, Okay, so this is going to give us the findings that are returned from our Sparkle query, and we can get the object value, and we can log that to the console. So if we do that at the moment, we're just using the standard Comunica query engine. We'll see that we can execute this. Examples, Ruben classes, Comunica. Going to fetch that, and we get an error. Yay, what's going on?
Did you provide the sources?
No, we have not provided sources, of course. So I've got a pre-prepared context. So this context, as Ruben said, has the sources that we want. And these sources are Ruben's website, which has some RDFA data in it, and also the FOF ontology. But because the FOF ontology is down at the moment, we're using a web archive backup of that. So now if we log that data, we can try that again. And yay, okay, so we get that Ruben's a person, and this was explicitly stated in his website, so everything seems to be working as expected, except we don't have all the rich information that comes from the ontologies stating that person is actually a subclass of other things. So what we can now make use of is this Comunica reasoning components, and it's going to make use of this additional context entry for rules, and it's going to apply all RDFS rules to that data set. So now we can add those results to our query, and we'll see that Ruben's also a resource, an agent, a thing, and a spatial thing. So we're getting much richer data in our results purely by just enabling RDFS reasoning. And this becomes useful, obviously, in a much broader variety of use cases than just checking which class you are. But before we go into one of those use cases, I also want to talk through what this example looks like in LDflex. So the goal here is to execute the same query, but this time instead of writing Sparkle, we're going to do it in this abstracted language. So this first 30-odd lines of code is just some boilerplate setup. You can actually copy and paste most of that from the LDflex website. And what we end up creating is this Ruben object, which is traversable in a similar way to a JSON object, except for the fact that we're actually going to lazily load the data, so we need to do some things asynchronously. So what I want to do is I want to get all the classes that Ruben belongs to. So I'm going to iterate over all of those classes. Again, I need to do this asynchronously. So I'm going to go const type of Ruben.a. So the way that we actually know that this A gets resolved to RDF type is we've specified that that's what we want to happen in our context, which is the same context as you have in a JSON LD context. So I've got A mapping to type in the RDFS vocabulary. So what we can do now is we can log that. And go into our LDflex example. And it'll take a second to process, but then we can see that we've got all these classes appearing. And that's because we are currently using that reasoning query engine here. And then we can continue to use other features of LDflex. So for instance, we can now traverse this type object to get its label. So we could go await type.label. And if it's undefined, we'll just return nothing. And we'll see in a moment our results starting to filter through. And now we're getting all the labels of these URIs. So this is kind of combining now having query, being able to query over multiple sources, being able to reason over those sources to get these classes, and then just having a few abstractions to be able to get things like the label out as well. So are there any questions there before I move on? I can't actually see the YouTube chat, so let me know if there is.
No questions at the moment on the chat.
Sweet.
But maybe some questions from the people here.
Yeah, there's of course a little bit of delay on the yeah. So let's also see a bit there. I don't currently have any questions.
All right, too easy.
Although I do wonder, I do have a question. I do wonder why whether there's a way to actually understand why Ruben is considered a spatial thing as well.
That's a good question. I'm not actually sure. I think that might be part of both. I'm not sure.
Can you prove it?
If we that's a very good question. So at the moment, the query engine that I've got here is using custom RDFS evaluation that I built into Comunica. With Inrupt, at the moment, we're working on, or have pretty well finished work to integrate the partway through integrating the iReasoner into Comunica, and the iReasoner does support proofs. So very shortly, we will be able to have proofs as to why we're getting results. And experimentally, we're looking into advertising those proofs through Sparkle Star annotations, but that's a little more experimental and a little more down the line as to how we advertise those proofs.
Yeah, and next to that, like being able to infer this and also take them into account while running your Sparkle query, probably that comes at a cost of performance, right? Like, can you elaborate on how much lower incorporating inferences inside your Sparkle querying would, how much lower it would go?
So there's a couple of factors there. The first is one, your rule set. So if your rule set is quite big and it requires a lot more information to produce the inferences that you're interested in. So if you've got RDFS rules, for instance, they require essentially all data across the sources, but you're only interested in subclasses here, then you've got an extra overhead in terms of your fetching, because you need to retrieve a larger amount of data to produce the inferences and then produce your results. In terms of the actual evaluation time on the inferences once you've fetched the data, that's not generally too much extra overhead. It's in general smaller than the network requests. And I've done optimization work in N3.js as well that kind of makes it millisecond or less to do these kinds of subclass inferences. So yeah, the computation time is fairly negligible compared to the network costs.
That's pretty cool. Thanks.
All good. So now what I'll do is I'll move on to a use case and what we're actually starting to use these reasoning functionalities for, which is schema alignment, which I also believe was discussed earlier, so it might be of interest to some other people here. In this case, we're going to do a fairly basic example, and what we're going to try and do is align between schema.org and FOAF in terms of determining who your friends are. And here what we're going to try and do is just look at all of Ruben's friends and find out who they are. So to do that, we're again going to use LDflex. And what we can do is we can go for, const person of Ruben.friend. So we're going to iterate through all his friends. And what I'm going to do is steal some logic here to remove duplicate declarations that might occur across different documents. Sorry about that. So let me move in this. So we've still got this iteration, but now we're just not going to log it if we've already seen this person as a friend. And if we do this at the moment, so we've got alt2rl enabled, but we don't have any information about the relationship between FOF and schema in yet, and we don't have any custom rules to align FOF and schema. And when I do .friend, we're actually looking over schema knows. So let's just see what happens given that information when we try and list out Ruben's friends. So we'll go person LDflex. And we're waiting. Data's loading. Internet's slow in Australia. And we get no results, which is not what we want because Ruben's a great guy. He obviously has friends. So why are we getting nothing here? Well, in his website, everything's declared in FOF, but we're looking through schema. So we need to actually make use of semantics here and do some schema alignment. Now, there's two ways of doing this. More than two ways of doing this, but two ways of doing this that I'll talk you through. So the first way is to make use of existing alt2rl rules. And if we look at alt2rl, it's a bunch of disgusting stuff here. So there's about 52 rules here. Never should need to read this as a human, but just to prove a point, there's these equivalent property rules. And what these equivalent property rules are saying is if property 1 is equivalent to property 2, then anything I say about property 1, I should also say with property 2, and vice versa. So we can make use of that rule and say that schema.org knows is an equivalent property to FOF knows and add that data to our query. So we're just adding one triple to our query. Here I'm doing it as an RDF.js store. I could just as easily add this as a local file or publish it as a gist and look at that gist. And now we've added that information. We can run that query again. And again, internet's slow in Australia, but now we can see we're getting this great list of friends for Ruben. So all we required in this instance was using the standard alt2rl rules for reasoning, and also to add the fact to our data that knows is an equivalent property in schema and FOF. Now, another way of doing this and achieving this schema alignment is rather than declaring this same as data, would to be declare a custom rule. So in this case, I've published on GitHub as a gist this single rule that says if P1 knows P2 in FOF, then P1 also knows P2 in schema. And Comunica is capable of dereferencing that rule and then using that rule again to produce our inferences. So if we run this query, we can again see that Ruben is friends with Peter and Tim and lots of other people. So this is really powerful. And even though this component that I'm showing is just with RL rules, we're already able to do a lot of schema alignment, and the possibilities are only going to grow as we add all the functionalities of things like I in the coming months. So that's really all I had for my talk. Are there any questions?
Yeah, I have a question. Actually, this is maybe quite cool because I got a message from a customer who is using LDflex, so he asked me to ask the question to you, Jesse. This is a customer who's watching on YouTube, I assume. This customer has used LDflex quite a bit over the last time, but has also noticed that it's currently a JavaScript library, whereas a lot of the rest of the Comunica ecosystem is in TypeScript. And also sometimes, maybe also the innovation is moving quite fast, but sometimes some of the examples are a little bit outdated or things are a little bit different. And it's also not easy because it supports a lot of things like solid pods and also Sparkle endpoints, etc. So from the developer perspective, where the developer can pick this up and sort of the ease of use, TypeScript, could you maybe give a little bit of an overview of what's next in that area?
Absolutely, and I can definitely empathize with that experience. I've encountered a lot of the issues that your customers facing there in the past when I've been doing my own development. And in doing that, I've looked into TypeScript rewrites for LDflex and kind of started on those. And to be frank, when I started those, I was a uni student trying to do that on open source time, so I did not have the resourcing to finish it. And Ruben is also maintaining LDflex on his open source time. Now I'm at Inrupt. I potentially, and this is all still very open, potentially in a few months, we'll have the opportunity to pivot back and spend time actually adding TypeScript capabilities to that library. And what I envision that looking like is type generation from Shackle. So you can declare the structure that you expect your data to adhere to, and then having all that typing applied to your path traversal. And at the same time, improving the erroring behavior within LDflex. But again, with all the caveats that that's not logged in, and if it does happen, it will probably be very late this year or early next year that I get around to working on that.
Oh, cool. But I'm quite sure that the typings that are underway will already be received very well. I know that this was a big thing that the developers there encountered. And I must be very clear, this customer I know is very enthusiastic about LDflex. So these are really like smaller issues that it's good to know that it's underway. And also I now realize that we can actually also create bounties for things that are not bugs and not features. We can also create bounties like, hey, make sure there are good examples, or make sure there's typings. These are actually just viable bounties in the end. I have a shorter second question, and that's sometimes people use LDflex and then they think, oh, this is really nice because it's more from the perspective of the developer. It's more natural to write these paths. But then also people sometimes wonder, oh, but how is this being evaluated in the backend? Is it still performant, or is it sometimes better for performance reasons to issue one big query and then to take out the bits and pieces that you need? So what's the story about optimization when you use LDflex?
So LDflex, I can actually show you this in code, might be the easiest way. So this is all Sparkle evaluation under the hood. So we've got this package called LDflex Comunica, and this is responsible for wrapping. So LDflex in this path traversal will generate a Sparkle query. So for instance, if I do Ruben.friends, that will generate the Sparkle query Ruben faux friends or selecto where. And then that will get passed to an evaluation engine. In this case, we're using Comunica, so we'll go through this very small wrapper, and that will just execute that query through Comunica. And then if you're doing something like Ruben.friends.names, again, that's just a Sparkle query, but instead using a Sparkle path or a BGP pattern, and Comunica will again just run that query. So it's all just Sparkle evaluation under the hood. Does that answer your question?
Oops, sorry, I had unmuted and also stopped my video there for a while, but yes, thanks. Yes, I think so. So this basically means that don't worry too much. LDflex abstracts some things away from you. It gives you a more natural developer experience. And of course, under the hood, it must still be evaluated in a performant way. But performance is actually already factored into LDflex development. So this means that I can basically reassure users of LDflex that generally this is something that is taken into account. Thanks.
Yeah, exactly. Performance always goes back to Comunica.
Maybe just one thing to add there. That's also a nice thing. The nice thing about using LDflex is that this is kind of an abstraction layer for application developers. Like developers can just use these LDflex expressions, and they should not be concerned too much about performance. Like the goal is that this LDflex expression is converted into a Sparkle query, and then Comunica should take care of, or should ensure that performance of the query execution is as good as possible. And related to that, there's also the fact that since Comunica will remain to be, or is continuously being optimized, applications using these LDflex expressions will also automatically become faster when Comunica updates without having to change anything to their code, really. They just have to bump the version of Comunica or LDflex.
Yeah, nice. And then it's better if you encounter a performance issue, report it as a bug, maybe even as a bounty. That's even better. And then it's basically you can offload this worry of performance into the ecosystem, because otherwise everybody starts doing their own optimizations. It doesn't flow back into the community effort. So actually, I must then say to people who are going in that direction, don't worry. Use LDflex, and if you find a reproducible performance issue, just simply report it, etc., etc. Thanks. Yeah, this gives a lot of guidance in how we can then proceed with I should say, very cool tool, LDflex. Thanks.
So yeah, Jesse, very courageous to do this this live demo, and it all seemed to work quite well. So so very nice. Also nice to see that. Like as far as I know, this may even be the first time where we see a live demo of federated querying and reasoning at the same time. So that's quite impressive to see. Just one more question from my end. Can you give a bit more details on how this actually works internally? So how do you do the reasoning at the moment, and do you have any plans on changing that?
Sure. So at the moment, we're doing strictly forward chaining reasoning. And what that means is we internally have an RDF.js store, and we will take the rules and the pattern or patterns that need to be evaluated for a Sparkle query, work out which rules need to be applied across all of the data sets, and then recursively apply all the rules and add the inferences to that RDF.js source. And then when it comes to doing the final query, we'll just federate over that extra RDF.js source in addition to the original sources to add those implicit results back. And if you might have noticed in the demo that in a couple of instances, person might have appeared twice. And that's why. If we don't apply distinct, it will get person from that implicit store as well as the original sources. And there's a couple of, I guess, semantic questions about whether we should be filtering that out or not. But that's, I guess, something bountyable if that wanted to be done. In terms of in the future, so with this usage, in the first instance, we will be using the same approach of putting back into that store, but I also supports backwards chaining as well, which means that we can start to exploit those capabilities, and we can also start to look into things like query rewriting for QL profile reasoning, which means that we don't need any intermediary stores as well. So there's lots of work to be done, but it's largely performance work over functionality work.
All right, that's clear. And I guess since all of this is also open source, people can learn more about your implementation if they are interested in seeing how it works.
Absolutely. And feel free to ask questions directly as well, if any documentation is not clear.
All right, it's time to go over to the final speaker of today, who is Pieter Colpaert, my colleague from IDLab. And he will be talking, well, the title of his talk is A Querying SDK from Research to Practice. So, Pieter, feel free to go ahead.
Yes, all right, thanks, Ruben. Yeah, but that kind of really in-depth technical demo that of Jesse, I feel like my demos are not even worth showing anymore. Almost like federated querying together with reasoning. That's like the killer feature I've always wanted in Comunica. So really cool to see that it's that thing is coming. It seems also that Enno in the beginning also was hinting towards it. Okay, at Termen network, at the terms network of terms, we are actually also doing some kind of federated querying, but we manually do the schema alignment. So that's I think a very big thing if it's landing in a stable way, even if it's only forward chaining. That's fine. Then I think it's going to be a great thing, or that Comunica will be much richer. But I'm here to explain a little bit how Comunica came to exist, and why we started building it, and why we certainly don't want to keep it into the academic atmosphere. So first of all, our vision on linked data or on data in general is that we've seen too much of these kind of architectures. When you're an organization, you think that you know everything, which is basically the closed world assumption. You think that you have all the knowledge in the world. So you just integrate a couple of data sets, put it on your central store, and then you say, okay, now all my apps are going to work on top of my querying API. That brings a lot of issues, as like just business wise, that these application developers over here that are going to build on top of your API, well, they want to they of course just get free computation power, in fact, from that server, as they will be able to put in any kind of question towards that centralized database, and will be able to use the computational power of that server for the app's benefits. If the app grows enormously in users, then the app itself won't really notice it, but they will be really happy. But the data publisher will use it will notice it in that case. And the biggest problem then is, of course, that the data publisher doesn't have any additional benefits or additional income in that sense. And that then the only, in case that it's really successful, the only thing that they can reside to is like micropayments or API keys on top of this, which I find personally a really bad solution, as you're actually going to limit the amount of reuse that you're able to do on top of your data, which is contradictory to the entire point of data publishing. You want to give the power to the many in order to innovate with that data. You want to be able to give app developers any kind of flexibility. And that flexibility is also already broken just by the fact that over here, if you host a querying API, you're going to limit it to a specific API, just like Sparkle endpoints. So if, for example, I go to dbpedia.org/Sparkle, I will only be able to speak Sparkle and not GraphQL unless I translate it, of course, myself. So what if instead of this system where a lot of effort is being put on this connection over here, what if we start looking at this part, the integration? If we can fully automate that, then we don't even need to fully formalize that query language maybe, and we don't need to really take a decision on query language on the publisher side, but we just leave it up to the consumer. And if the data consumer can choose the query language, can choose how it processes the data, how it runs the query evaluation, then we give true flexibility to the app developers. But we also make sure that the costs of querying is carried by the right party. If the app developer needs larger computational power, it's their servers that they can enlarge, or it's them that can add something. They don't need to just ask the publishers in order to ask something. Good. So in order to get that vision rolling, and it really started from the perspective of, hey, Sparkle endpoints don't fulfill that vision of just a query language that can resolve any of my questions, because we saw that some Sparkle endpoints would go down, and we saw that Sparkle isn't fit for purpose for any kind of querying system, like what we discussed before: autocompletion, language negotiation, geospatial queries. Although, okay, there's GeoSparkle, but it doesn't do everything, and so on. So what if you want to extend, or what if we want to study Sparkle and want to make sure that we get the bad parts out of Sparkle, the fact that Sparkle endpoints always go down, but that we can get the full power of Sparkle already towards everyone at a lower cost. So that's why we started working on triple pattern fragments. And that was the first specification when it came out. I think it was, the first version was in 2014. Although 2015, 2014, yeah. I'll have to look that up to be sure. But the initial idea was, hey, instead of doing the full basic graph pattern in Sparkle, let's take out one triple pattern and let's put that on a server. So we started building that really lightweight interface on the server side, but on the client side, we really needed to get the Sparkle querying and Sparkle query evaluation running. So that's when we created what we then called the linked data fragments linked data fragments client. The linked data fragments client was pretty much tied towards triple pattern fragments, and mainly did the joins between all these triple patterns, so that on the client side we would be able to do basic graph patterns. The initial ideas behind that algorithm are still pretty core to what Comunica does today. But importantly is that triple pattern fragments were not the only interface that we envisioned with linked data fragments. With linked data fragments, we saw an entire axis, and the entire axis would go from data dumps, which are really big files, like the JSON-LD file that Wouter mentioned that people are uploading to Triply, towards entire query languages over HTTP. And over here, we already know subject pages, and we also already know triple pattern fragments. Now, why wouldn't there be other kind of interfaces as well on this spectrum that we would be able to use in order to do query evaluation? And if there's a Sparkle interface available, why wouldn't we use it in a linked data fragments client? So so that conclusion was like, hey, okay, we really need to be able to query over heterogeneous sources. So we need to build something which we started calling Comunica in order to have a modular system across this entire spectrum. And I think this is a demo that opened my eyes a couple of years ago. Was that the promise of linked data is just make sure that you formalize the vocabulary, that you have an application profile, maybe like a shackle shape or something. And if you make sure that you can do that within one data space, that you adhere to the same vocabularies, then you will have semantic interoperability and you can query across everything. But that wasn't really true, because you still needed to physically bring the data together before you would be able to do that. Now, that last step of not really having to bring the data physically together is for me solved by Comunica, in that sense that that in Flanders, we have the two biggest cities in Flanders are Antwerp and Ghent. They have a lot of museums, and which means that these museums have art collections. Well, Antwerp decided to map their art collections towards linked data. According to the Flemish standard, which is called, all our vocabularies start with Oslo. Oslo is the open standards for linking organizations, standardization committee in Flanders. And there is an Oslo cultural heritage vocabulary that was standardized for entire Flanders, and Antwerp started complying to that one. It's for the ones that know the cultural heritage domain. It's based on CDOC CRM. If you would know that standard. Ghent would do the same thing, but the problem is that they didn't really that Antwerp and Ghent really don't want to both have the same kind of querying interface. Ghent actually has a Sparkle endpoint, and Antwerp just said, "Hey, we don't have triple store infrastructure at Antwerp. We will just publish it as triple pattern fragments." But now the biggest, the coolest thing about Comunica is that we can just add both of them towards our data sources, and that we can execute that query, and that results. That's of course what could be going wrong. I tested it right before the presentation.
Is the endpoint down again?
Yeah, it was down before. Then I triggered people to make sure that it was up again. So this endpoint is up. Okay. Then no valid Sparkle query results were found. Okay. Yeah. Magic. Okay. So right now you will see that some query results will be streaming in, and that it sometimes shows that something is resulting from data.antwerp and that other things are from city.ghent. So this is something quite cool that we are now able to show these two cities without even agreeing on the kind of interface, but they do agree on semantics. Are able to just have a federated query across the boundaries of the cities, and not only TPF and triple pattern fragments and Sparkle endpoints are on the linked data fragments axis. Many other researchers also started researching different types of interfaces. For example, in the early days in 2015, Joachim, one of our colleagues, extended triple pattern fragments with substring search on top of the object. So it was then again the entire server that would make sure that substrings would resolve on objects, and that you then would be able to do starts with in Sparkle. That would also be convenient. Then binding restricted TPF was by Olaf Hartig, in which he said, but why restricted to just only one triple pattern? What if we can immediately send star shapes also to the or star patterns to the server and get more complex results from the server? And he formalized that in a really interesting way. Then later on, there was also Smart KG, in which they said, but instead of just shipping the data itself, why wouldn't we actually do the HDT, so which is the index file that's behind a triple pattern fragments interface? Why wouldn't we ship immediately the entire compressed file so that you can use that in the back of your querying system to then later on be able to have different queries and resolve them much faster, because all the data is already available then in your system on the client side in order to be queried. So that's also really interesting work, Smart KG, that actually reuses the same ideas behind linked data fragments. And then one of the most recent additions to the linked data fragments access is, I think, the tree specification, something that was already mentioned by Wouter and Enno before. And that's really towards materializable fragmentations of your data. So if you take your entire data dump, tree starts from the observation that you can just fragment that data dump in different parts, and that you can code Comunica in order to recognize which parts of the data it needs just in time in order to answer that question. And tree has specific relations, so it's called tree because you can really model any kind of search space or search tree with that vocabulary. But you would be able to have to say, okay, my data dump, it's divided in a western and an eastern part, so that if you're only interested in something that is located in the western part, that you only need to download that fragment and that you can disregard downloading the other part. But then if you really go towards a lot of fragments, then you can get some queries really performant. And this is what we applied. As I said before, route planning is one of the use cases that I really like, and we applied that on a roads network like OpenStreetMap. You can there are linked data or RDF versions of OpenStreetMap available. If you then process it and fragment OpenStreetMap in tiles, you would be able to use that linked data just in time in order to boost a route planner that can just say, okay, I only need these tiles in order to answer that question in order to route across the roads from A to B. So there's also a live demo here. Going to post the link later on, but you can play with it yourself now. Good. Then something that was also already shown by Enno, in the same way as geospatially fragmenting your data set, you could also equally as well fragment it based on substring. And now one of our ideas was, okay, hey, if we do this on substring, then we can actually do a file-based auto-completion service. Like you could just use GitHub Pages, for example, in order to just fragment a data set into specific parts. And over here we actually used GitHub Pages. Let me quickly okay, no, this one doesn't use GitHub Pages, but it is also a static file host that would just say, look, this is one file that just contains that. Okay, it's a trick, so it will open up like this. But the idea over here is that you get just fragments based on their on a substring. And now I lost my tab. Okay, no, it's over here. Now, over here, what is interesting also privacy-wise is that we won't send the full substring to the server. It's just traversing the tree towards the right towards the right fragment. And we can also do federated searches over here. For example, if we are not only looking for street names, but we are also looking for public transit stops in Flanders, and we are looking for technology park, then we'll find both the bus stop as you will find the street name in a reasonable amount of time, because I've been doing quite some lookups right now. So all of these queries that I'm running now are actually just hosted from served from cache. So over here, you will probably see that everything comes from cache, so I don't need to do any actual HTTP transactions anymore. If I now look up something with a totally different name, let's say Station Street, you will see that that some requests will still have been carried out towards the server. So that's basically the idea behind that. And in order to achieve that, we also had to create a new query actor in Comunica. So there was so we didn't use Sparkle. We used a new kind of query actor that we started implementing. It was built on Comunica v1, and now Comunica v2, of course, has been launched. So so now we are looking into making sure that we can go towards a much more coupled way of making sure that this substring fragmentations can maybe land in Comunica. But that then also these substring fragmentations can be used and leveraged within even Sparkle queries. So if you would do a string starts with a function in or filter in your Sparkle thing, that you'd also be able to get an answer faster. So in that sense, Comunica became really an experimental research framework in the sense that you would be able to quickly implement certain features in it, that you would be able to say, look, just test it out, use a slightly different configuration and see how it works for your use case. But also because of that modularity, you would be able to, as researchers, quickly say, I'm going to test this extra module that I code next to it. You don't need to take a fork because you can code everything as modules. And in that sense, you can really test Comunica to work with different in different scenarios. So you can have a pretty easy baseline based on the default configuration, and then say, look, in order to make sure that the query set runs better, I'm going to try to have a different configuration that actually works better on top of that data set. Okay. If you're interested in all the publications, there are quite a few publications written already. You can read them there. But more interestingly and more importantly than just the academic work is that our open source tool is getting picked up by industry, and in that sense, yeah, as people interested in mainly research, that often collides with industry interests. We are not going to do stuff we're not going to code stuff into Comunica that doesn't give us a clear vision on a research pipeline or getting more research funding at our lab. So it was for us really clear that we needed to spin it out. But of course, having a commercial model on top of Comunica is, I think, the wrong reflex, because if technology transfer from academics towards industry can only be scale ups and spin-offs that become that have their own for-profit business model, then I think we are not going to be able to spin out a lot of open source products. What I do think, instead of a business model, is that we need a sustainability model. We need to make sure and give an idea towards industry that if we deliver some components from academia and we say, look, build further on top of that there's still an entire community that can deliver support, because, well, it's industry, so there are budgets spread around that can make sure that the roadmap itself, even if it's not relevant for research, can be further evolved. So this, for me, is a very first, this association, or launching the association, is a very important step at IDLab in order to further, this model to further apply on top of different open source products that we will have. And in that, I think for industry, what we want to deliver, the selling point almost of Comunica then, or this association model towards industry, is, look, you funded somehow our research, whether it is through taxpayers' money or whether it is through a direct bilateral contract. And in the case of Enno, it was actually a bilateral interest, and they actually funded research. But of course, they need it in production. So what we need to do is to make sure that we have an association model in which they have equal saying rights and equal power in order to influence the roadmap, so that it can also be fully taken up by industry. In that sense, a fully transparent bookkeeping will make sure that everyone can have trust in order to jump into the association. And I also think it's also a cost-effective way of doing it, because if everyone needs to build a Comunica inside their own company, they're going to have a lot of work to do. So that's why we do it as open source, as a commodity towards an entire playing field of companies, in which they can collaboratively fund a tool that does web querying for them, and that way I think we will make sure that we create a world we can proud of. So the Comunica Association for me is the first of more associations that will be spun out of IDLab. At least that's what I hope, that we can really call this a success story. And I'm really, really proud today that we can officially launch this this association. Thanks.
Thank you, Pieter, for the nice presentation. Are there any questions for Pieter?
Yeah, a short. Oh, sorry. Let's first do YouTube questions, Ruben, if available.
I don't see any at the moment, so go ahead.
So, question, Pieter. You mentioned some things like caching and also the collaboration with industry, and then you see, okay, they actually need this. So that's where the gradient of complexity in query languages moves towards actual use instead of having super complex or flat file download. There's lots of stuff in between. If you look at the original internet, when the original internet was created, and then people started creating HTML tables in order to have style, and then that's W3C stepped in and said, oh, that's not going to work, and many big images, and it's not scalable. So they came up with CSS, and CSS is a very lightweight way of doing things. And they also saw that people were having very large images, and then they came up with PNG, and with more efficient image formats became more popular around the same time, and because it had to be supported on the internet. I think this is also where you are moving, and also where the Comunica community is going, right? We're basically going, okay, these things work, and these things don't work, and we're basically steering a little bit. But is it sufficient to only do that in software, in like development, Comunica, or does it also need to go back into standardization? You already briefly touched on that before, but I just wanted to hear your full opinion on that.
Yeah, you're now going the other way than what than my thought train was going, in the sense that, for me, it is clear that standardization is something where companies are coming together in order to make sure, hey, we need to do this together, otherwise we don't have a business field at all in order to operate. So we need, of course, a market to operate, and there some standards are necessary in order for the entire market to run more smoothly, more efficiently, and so on. So I think your example of the early days of the web is correct, but still the extra problem on top of that is, okay, you need a way, you need a collaborative aspect as well to then translate these specifications into actual open source software. So for me, this role now, like querying the web, is still in its infancy almost. There are not many organizations that actually use federated querying in a production environment. But I'm still think that we are building towards that, and the entire linked data, the entire idea of linked data all these years has been towards building smarter clients in that sense, and making sure that we can do better querying. Now that we actually get industry interests, I think that we cannot only say we're going to do specifications. We also need to go towards these implementations and work together on these implementations. Otherwise, we're going to probably going to do things very inefficiently worldwide. So yeah.
Pieter, I had a question for you as well. I was wondering about the place of event streams in your access. How do you look at that? For me, it's still quite a difficult one to plot on the X in there, because it still feels like all the data is there, and maybe you fragment it, but if you look at the event streams, then you really need to do a lot more bookkeeping somewhere in the process. And can you tell a little bit more about your views on that?
Okay, so the question, yeah, leads me to first explaining this. So we have the entire linked data fragments access. The problem is, if you're a data maintainer, then at some point you need to say, hey, I've put a lot of my efforts in maintaining that data set, but I need to publish it somehow. Which API do you choose in order to publish it? Will it be Sparkle endpoint? Well, no, we mentioned that we were against that. Will we go towards just a data dump? Well, okay, sounds interesting. That's maybe the least that you can do, but the biggest problem with the data dump is you still need to make sure that it's updated. Can Comunica immediately work with a data dump? Well, if it's going to have to parse the entire file, so as long as it can parse it streamingly, it's going to work, I guess. But of course, we can imagine more also more efficient interfaces that Comunica itself can then work with. So for me, that data dump is in the first place not a solution, in the sense that that also the data is going to update later on. So we need a way to then synchronize it and make sure that other people can take a copy of that data dump or of that data set maybe, and also always keep in sync with it, but then host specific fragmentations or specific indexes or specific other kind of interfaces on top of that, so that Comunica can query across it. Because also, even if we disregard Sparkle endpoints, then we have still all the different kind of fragmentations that you can make. You can make geospatial fragmentation, substring fragmentation, time-based fragmentation, and not only just one type of time-based fragmentations. No, you can make them on different kind of properties, and maybe you can intertwine different kind of fragmentation strategies as well. Like you could first do time-based and then go into geospatial-based, and then afterwards do substring-based, for example. Because if I would like to answer a question saying like, give me all the street names that start with the letter A in the city of Ghent, then somehow I will need to do path planning across that. But given that you cannot just expose any kind of interface at the data publisher side of any kind of fragmentation, what led me to inventing linked data event streams is, since we cannot invent any kind of interface, we need to study what the minimum is in order to make sure that everyone else, every third party in the entire ecosystem, can set up any kind of other kind of fragmentation. And that became linked data event streams, because linked data event streams is not a data dump. It's slightly more than a data dump. It is the data dump of the full history, but you can also efficiently synchronize that full history later on if you want to keep it in sync, of course. So that event stream based approach is interesting then if you put it on the web, because another server can say, I'm going to keep in sync with it, but while keeping in sync with it, I'm going to order and republish this data set in a certain different kind of interface, a triple pattern fragments interface, maybe a Sparkle endpoint. I'm going to make it available towards everyone, so that Comunica can then do smart source selection maybe across the entire ecosystem and select the right interface just in time to do it. So that's why I also avoided talking really about linked data event streams in this talk, because I think it's something that happens before the specific interface that Comunica will reach. But then again, also in order to do the synchronization and replication, you might sneak in some querying in there. Like, I'm not interested in synchronizing all the addresses in the Netherlands, for example, or all the artworks from all of the Netherlands. No, I'm only interested in everything that's available in Amsterdam. So in that case, you might then also, while syncing and replicating, you might also take into account some Comunica features that can do filters on top of it, and then you really come into querying again, while actually just trying to solve the replication and synchronization step. So that's why now the linked data event streams client, which main focus is replication and synchronization of data sources on the web, that client is also being written in Comunica, so that then later on we can extend it with all the functionalities that are already available in Comunica in order to synchronize more efficiently.
Okay, thank you. Yep. For me, it's very interesting to think about who has which role in the network, because we are, of course, at the Digital Heritage Network in the Netherlands. We are constantly thinking about what our role is, what kind of functionality we need in our common infrastructure, and what is the role of all different providers that build services on top of that. And for this point, for the event streams, I'm still really looking for clear definitions or clear examples where this is actually being explored or maybe implemented. So is there, or are there already clear examples to look at, and that tells something more about what is the logical role of a certain party in this chain? Is this being done in the Ghent project maybe, or is that not clear?
But Flanders is heavily investing in linked data, the idea behind linked data event streams at this moment, and over there we are also defining these business roles within the ecosystem. And even worse, right now, linked data event streams is really built from the perspective of, okay, I just have a data maintainer that publishes data. But it gets worse from the moment that you also include the write aspect, like how do you write towards a data set, and how do you then keep in sync all the different derived sources on top of that, because you need to know where you want to write, what the write model is, and so on. And that's then also in the same exercise what we are trying to solve for the Solid project. So the personal data project, where also different apps are writing data to your own personal data storage, and then later on, okay, well, we need to query it somehow. And I think Comunica also within the Solid project, Comunica will be a very important building block, and I think that's also why Inrupt is also one of the partners. Is how do you query this whole vast amount of personal data, but maybe also while you're querying that vast amount of personal data, how do you immediately also do federated querying across your personal data, including all the public data that's already out there as well? So all the roles, if you consider not only the role of public data, but also on personal data and shared data of everything that's in between somewhere, company data that needs to be sold, and so on. Then we try to research what roles to put on that. We get some inspiration also from the data spaces terminology. So there's like the Gaia X and the International Data Space Alliance that really do the exercise on, okay, what are the organizational roles within that kind of ecosystem. But unlike IDSA and Gaia X, we really first want to try to put it into spec and try to get that these specifications out there, and then also make sure that it matches towards business processes at the Flemish government, in order to then come out and say, like, look, this is how we see a data space being implemented with the right roles put at the right place.
Very interesting. Thank you. Yeah.
All right. I see we're running a bit late already, so I think this is a good time to wrap up the event. I would like to thank all of the speakers again for their very nice presentations. So for the people watching via YouTube, the recording of this live stream will of course remain available. And the plan is also to share the slides of the speakers that wish to share them on the website. So do keep an eye out for that. And other than that, have a nice day, everyone.